All right, guys, today we're transitioning from our crystal growing experience, and it was quite the experience, into precipitation reactions. And I want to use your thoughts and what you did in the crystal lab to share with your classmates, because everybody worked alone on the crystal lab. So I want you to create a slide. Here's the rubric for what we're doing today. So it's a reflection. You're going to get 2 points for discussion of your crystal research, 2 points for your discussion of your lab results, 2 points for your solubility definition in your terms, 2 points for the role solubility played in your crystal experience, and 2 points for discussion of what you learned and what you will do differently and why. And the why is the importance. That's 10 points total. So that's the rubric, and here's your discussion. Reflect on your crystal lab. On one slide, summarize your crystal research and the results you achieved in the lab. Define solubility in your own terms. Discuss the role solubility played in your crystal growing experience, and discuss what you've learned and what you will do differently when we return to lab and why. Because you know that we're only suspending the crystal lab temporarily while we go into precipitation reactions. Then we're going back to the crystal lab. So this is transitioning into precipitation reactions, which we did do last year. So I know a lot of us, I'm going to put the rubric back up, remember those precipitation reactions well, but I just want to see how we transition from them. At the end of your slide creation, I want a short presentation from each of you, like a minute or less on your slides, so you can share with us what you got. And this will count as your lab reflection.
Okay, this is a demonstration of my use of Google Classroom with my college chemistry class. I gave them an assignment and I wanted them to do it as homework so that they could create their own solubility rules and comment and share on each other's. And this demonstrates how the students in that class created their own solubility rules and commented on each other's to discuss what they thought. So it shows the collaboration between the students. Google Classroom is really good for that. And you can see it allows them to talk back and forth and allows them to think together. Another thing that I use Google Classroom for every week in this class is I post a question that's homework related so that the students can use each other to answer homework questions. It kind of forces them to collaborate on questions, and whatever they can't answer with each other, then we solve together in class. So this shows, this is an example of the students talking about the homework that was this week, posting about it, and right here you can see this student had a question that was homework related and this student answered it. So this works out well. And then if anything's not answered here, we cover it in class. Another thing that I'm using this week, which will be an assessment, a follow-up assessment with this chapter, is a quiz in Google Classroom. I use Google Forms to create it. This is my first time doing that. And it'll be a multiple choice. You can see it's saved there. The students will take the quiz. It'll only populate when the students are ready to quiz tomorrow, and it'll grade it as soon as the students are done, and they'll be emailed their grade. And I can also edit it to show them what they got wrong and how to make it right. So this is some of the ways that I use Google Classroom with students to incorporate media in my classroom.
Anybody need more time? All right, so we're done. How do you guys want to do this? Do you just want to start at the front and work your way back?
Oh, we could go to the side.
Oh, that's fine. Okay, let's see.
Click on present.
Oh, and then you have like the big. Bonnie,
Escape
first up.
and reload.
Escape and reload it.
Me?
Yeah.
He cut it out before you
Up.
No.
present. I remember.
All right, Giovanni.
Alright, I said solubility is an ability of a substance to dissolve in something. The substance which is being dissolved is called a solute, and the substance in which the solute is dissolved is called a solvent. And in my crystal lab, through research, I grew interest in copper sulfate because of its nice shape and blue color. In lab, I was successfully able to grow my seed crystal, but was unable to grow my seed using multiple strategies. The reason I failed in this lab when it came to growing my seed crystal was that my solution wasn't saturated enough and the copper sulfate wasn't completely dissolved in the water. What I learned is that I should use less copper sulfate so it can dissolve better. What I would do differently was use the other form of copper sulfate. I'd use the crystallized form instead of the powder, because through research I found out that many people use the crystallized form because it's easy to grow crystals from.
Excellent. I like it. Thank you very much.
Okay, so my definition of solubility, which was very similar to Giovanni's, interestingly enough, is the ability of a compound to dissolve in an aqueous solution or water. And this is tied into my own lab because it has to deal with the amount of chromium alum that I use to dissolve in that set amount of water. And I also had to find the perfect amount of solution to create to make that supersaturated solution, to make a good seed crystal. And through the research that I conducted, I found that it was necessary to use 100 milliliters of water to 60 grams of the solvent of chromium alum. Otherwise, from the testing that I did, it wouldn't work so well. And I found that for several different labs online. And then in the experimentation, that 3 to 5 ratio of 3 grams to 5 milliliters of water is the most prime amount that you need, because otherwise, if you put too much in, it's going to make too many seed crystals, or it's going to make clumps of crystals rather than trying to build off of one crystal, which is where that perfect saturation ratio is. So that way, if you want to make a good crystal, one single one, you need to have that nice ratio. And in the future labs, I plan on continuing that process of using exactly 3 to 5 for making one crystal.
And that worked out well.
Yeah.
Because you got some good, single, beautiful crystals. All right, thank you very much. Cole.
Solubility is the amount of a substance that can be dissolved in another substance. And the solubility played a role in the crystal lab because I had to find the right ratio of magnesium sulfate and water to form the best crystals. And with the research I did, I found out that magnesium sulfate forms the best crystals when it's cooled rapidly. But when I actually performed the experiment, I didn't see any changes between putting it in the fridge to cool it rapidly versus just in the hood.
Yeah.
So, but I did see that when I put it in the hood, I was able to maintain the pink tint of the magnesium sulfate. So I'd probably keep leaving it in the hood to cool instead of cooling it rapidly.
That worked best for you. Plus,
Yeah.
you were the people I've talked to, people aren't usually able to maintain the pink tint. And it's, you know, how we've discussed before, things don't always work out the way we expect them to. You're right. Thank you, Britt.
Through research and through experiment, I learned that crystals from crystallized compounds form solid crystals in little time, which make them hard to check at the right time. Oftentimes, when I went to check crystals, the solution was completely solidified at the bottom of the beaker, making it hard to extract one crystal. My definition of solubility is the ability of a solute to dissolve in a liquid. I don't think solubility played a role in my lab. Sodium thiosulfate is already a crystallized compound, so I only melted the crystals to make my solution and then submerged a seed crystal into this cooled solution.
That's right, you had a different technique going on.
And using crystallized compounds as a solution hardened extremely fast, and it's hard to get results if you do not check at the right time, which I never did. So next time I will try to incorporate solubility into my lab, and maybe I'll get better results.
Good job. Thank you. Morgan.
I use sodium thiosulfate
in the lab to grow crystals, and through research I found a lab that suggested creating a supersaturated solution for my crystals to grow. And I rapidly mixed the solution for the seed crystals to dissolve, and I added a seed crystal to the solution, and the crystals grew instantly. And when the solution is mixed and can no longer hold any more of the substance, that's the solubility of the solution, and the solution becomes more saturated. And by adding so much of the substance, my solution was really super saturated, and that meant like a lot of the substance was left over. There were big pieces of the seed crystal at the bottom. Acid solubility was a substance's ability to dissolve in a solution. And based on my results, I decided to look further into and research how I could grow the crystals differently from that solution. And since they grew instantly, I found a technique that used pouring the solution onto a seed crystal and growing it.
That's interesting. So you're going to stick with the sodium thiosulfate? That'll be interesting. I can't wait to see how that works out. Thank you. Good job. Nicole.
I define solubility as the ability of a solid to dissolve, or solute to dissolve in a solvent at equilibrium. I use ferrous sulfate after receiving a list of solutes that have grown crystals in an effective manner. What I did not know was to what to expect from this ferrous sulfate. I found that if the ferrous sulfate and the hot water did not reach equilibrium, that I would not create the best solution. In my first attempt, I did not let the water cool down, and I started to decant the solution as soon as it was done dissolving completely. And every time muddy brown substance would settle at the bottom of the beaker, I would then decant more until the water was of a lime green color. This grew my first seed crystals, and when I went to do my second attempt, I actually let the solution sit for a couple of days, then decant it instead of doing it every single time. However, as soon as I placed the seed crystal in my new solution, more muddy brown substance grew at the bottom, so it wasn't completely decanted. In my lab, the solubility plays a big part because the solute must be completely dissolved in the solvent to make sure that all of the muddy brown substance will form at the bottom of the beaker the first time. In my lab, equilibrium is the most important because if I have too much in my solvent, and if I have too much solute in my solvent, then the solute would not dissolve, it would sink to the bottom. What I want to try to do different is instead of starting with the ferrous sulfate already prepared as a solvent, I want to go ahead and make my own ferrous sulfate.
Right.
See
That'd
if
be
it
good.
will grow its own way.
That's what you're going to try next time. Good idea. Thank you. Lauren.
Okay, based off all the research I performed before starting my labs, I decided to use aluminum sulfate and copper sulfate to produce two different forms of crystals. I found off very quickly they both produce very large seed crystals or clusters. And throughout my experiments, I discovered it's very vital to obtain a maximum amount of solvent in your solutions. There's times where I was really impatient and I'm like, oh yeah, that's enough solvent in there. And I saw very little growth to no growth at all in my crystal clusters. When other times when I took the time to be patient and make sure I was at that super saturated point, I saw significant growth and the crystals usually doubled in size. From these observations, I've determined solubility is a material's ability to break down completely, transitioning from a solid, distinct substance into something that's indistinguishable. Continuing on, I plan to do some more research to try to obtain a single crystal instead of a cluster, and I want to try to perfect the saturation level to find out exactly how much solvent to solution, that kind of ratio, what I need to do to get it perfect.
Sounds good. And you've had great success. So are you going to stick with the clusters too, or go more for the single crystal?
Because of the competition, I think I'm going to continue to grow my clusters, but like a personal goal is I want to try to get that copper sulfate to be one crystal as well.
Good job. Good job. Thank you. Zach.
Hi, so solubility is not a substance that can be dissolved in an amount of liquid to produce a saturated solution. So my research included making the best supersaturated solution, different substances to make crystals, and information from Miss Rulick's class at YSU. My lab was not a success for 2 reasons. I used darker substances causing the solution to be darker, making it harder to see the granules floating around in the solution. And for the lack of hot plates and stirring plates, I used a Bunsen burner, but I was unable to maintain a temperature of 70 degrees Celsius, and I had to stir by hand, so it caused room for human error.
Right.
The first reason for my lab not being a success is how solubility relates to my lab. I did not create a supersaturated solution, or I oversaturated the solution. In crystal growing, you have to make the saturation just right. Next time, I will try to use a hot plate so my results will not rely on human error. I learned that for dark solutions, using a flashlight will show granules, and also I'm finding methods to meet the point in which the growth rate and nucleation rate come together to grow the best crystals, and most of my answers deal with entropy and thermodynamics.
Awesome.
And if you go to the next slide,
Other than
there's
this,
a picture of solubility solution.
awesome. That's exactly how it works too, right?
I had more pictures, but for some reason,
She
Google's
has
not
to close
working.
out.
Yeah, Zach, you added them after she presented it.
Do you want me to
You can.
Yeah, close out.
escape?
Yeah, and then just
And
present
then give it a
again.
second and re-present.
The top right is one of the darker substances I use, chromium potassium sulfate, and then at the bottom it shows the growth rate and nucleation rate, and where they meet is where the best crystals will grow.
This is where all the frustration comes in. You know, all the papers I've given you on crystallization, there's, one of them is like, be patient, don't check your seeds, they're not going anywhere. But there is a fine line between the temperature and growth rate, nucleation rate. If you have too many nucleation sites, that's bad. Not enough nucleation sites, that's bad. So it takes a lot of patience and persistence with these labs, right? Good find, Zach. All right, guys, thank you very much.